pause this here. I think I just want to walk you through, and I chose a card stock, right, a little thicker, and I wanted to be able to still highlight and write stuff, so that's why I chose this color, not like a bright red or anything like that, because it makes it challenging to highlight. So when we look at this flow chart here, the first thing that we're going to start you're going to have to ask yourselves, in this scenario, does the order in which I arrange things matter, right? The question should give you some hints. I gave you some keywords here. Let me just zoom into those a little bit, maybe. That's why you have your own copy, right? But if you have specific roles like president, vice president, secretary, coming in first, second, and third place, things like that, that should be an indicator this is permutation, right? Password is so a giveaway. It's a dead giveaway, right? Because if you type in, even if you get the case wrong in reality, lower versus upper, or if you go 1001, it's the wrong password, right? So order matters. Codes, postal codes, license plates, stuff like that, it would all fall under the permutation category, okay? And then you split it up, right? There are cases, so I'm just going to follow that branch, the left side, which is what we spend most of our time. We spent on this permutation branch, right? And then you have cases where repetition is allowed, or you can also say that you have an unlimited supply, right? You have digits 0 to 9 that you can use, or letters, all letters, upper, lower case, or whatever. Then if repetition is allowed, if there are no like sort of restrictions put on you, then really the question turns into n, right? This is the total number of options to the power of r, and r, remember, represents the number of slots you're trying to fit in. So on the quiz, right? On the quiz we had making a code, right, with digits 0 to 9, and let's say you're making a four-digit pin, right? That'd be 10 times 10 times 10 times 10, which is 10 to the power of 4, right? Like you're making a 4-digit pin, 10 options per slot, right? So that's repetition is allowed. That goes down this branch. Then the other branch here where repetition is not allowed, you have a limited supply. So that it could apply to passwords as well, numbers made, letters in a word, right? People. You can talk about, like, if I tell you have cards 1 to 9 in a bag, and you're trying to make a number with those cards, that should be a keyword for, hey, as you're grabbing, your options are shrinking, right? So then you turn into, you can still use the fundamental counting principle. Anytime there's a permutation, fundamental counting principle is always an option. But we then introduce the NPR scenario, right? From n number of available options, we're picking our number at a time, right? So let's say you have 8 people and you want to arrange groups of 3. There's president, vice president, treasurer, whatever. Then it'd be an 8P3, right? 8 pick 3. Or if you're just arranging 8 people in a row, 8 pick 8, right? Because you're arranging those 8 in that row. And now it gets tricky. So coming down this branch, if there are any additional conditions or restrictions, that's what we spend a bunch of time on as well. So let me zoom out here. And I hope this actually helps you, not like if it confuses you, just tear it up, shred it, chuck it, right? But I hope this helps you a little bit to just gather your thoughts. So what are additional conditions or restrictions, right? If one or more conditions do not overlap, just use the fundamental counting principle or NPR, right? If one or more conditions do overlap, so you're like, what do you mean, Mr. Dixon? What do you mean overlap, right? Well, remember the quiz where it had to start with an A or a B, but it ends with a vowel, right? You're like, wait a minute, A at the front affects the number of vowels at the end, right? So there's an overlap there. You need to split that into cases, right? And then you add up your answers. Another branch that you can come down to is there could be some grouping mentioned. That is a pretty like it's a dead giveaway, almost a grouping, right? They'll tell you, hey, these two people need to be together, or these three, or these cars, right, need to be together. And then you just follow the formula for grouping, right, which you should have on your study sheet. If you ever have identical or indistinguishable objects, you need to divide, right? Your arrangement needs to be divided by the number of identical objects that, and that's the Mississippi, right? Or words that have doubles, or marbles are identical in color, stuff like that. Balloons, you need to divide that out. And watch for identical, indistinguishable. There's another branch here. If it's ever pathways, right? There are your 3 pathways options: no bottleneck, 1 bottleneck, and 2 necks, right? Sorry, I couldn't fit bottlenecks in there. And so then those are your options there. Okay. So basically, permutation takes up most of our paper here, right? Notice that. And I will go over a bunch of questions today and tomorrow, and I will kind of use this as a guide, right? Like I'll go back to this, like, hey, see how this flows here, and then let's go over to combination here. Order doesn't matter. So hands of cards, teams, committees, groups, ice cream flavors, pizza toppings, Slurpee flavors, right? Like if you make a Slurpee, Coke, Sprite, or dragon fruit, whatever, frog water. It doesn't matter, right? Like if you just mix those flavors in there, some of you will disagree, I know, but in theory, it doesn't matter. The flavors are all mixed in there, and the order doesn't matter. No specific jobs or positions are mentioned when making teams or groups. Okay, so then you branch off to, you have 2 options. If it's just making R groups from n available objects, then it's just NCR, or this notation here. Don't let that throw you off. It's the same thing. But what if you make groups with 2 or more subgroups? What does that mean, Mr. Dirksen, right? A hand of 6 with 2 red cards. What it really means is that you have 2 reds and therefore 4 blacks, because remember, 2 and 4 should add up to 6, right? So when a question says that, that's what they mean, and then you break it down into, right? From 26 reds, you choose 2, and from 26 black cards, you choose 4. Note that this question is actually saying exactly 2 red cards, not at least or 1 or more or at most, nothing like that. It's kind of saying exactly, even though that's not part of the wording there, right? There we go. And zoom out. The last thing here is direct reasoning. Direct versus indirect reasoning. We started to talk about that last week. Do you remember that at all? Or did the long weekend kind of do like a format, delete all memory? I don't know if it did. But direct means basically, I will do this. Direct is when you add up all your cases. Indirect is when you have, right, you end up subtracting things, right? So use this strategy when you see at least, at most, no more than, and so forth. So let's talk about the direct cases. You have 5 cats, 7 dogs, right? And so if you make teams of 3 with at most 2 cats, right? At most 2 cats. Then you obviously are saying 0, 1, or 2 cats, right? But since you're making teams of 3, if you have 0 cats, that means you have 3 dogs. 1 cat, 2 dogs, 2 cats, 1 dog, right? So you would write the combinations like that. You would add up all these answers. That's the direct way of doing this question. Indirect, let me go over to here. You would go total minus the cases where you have 3 cats, right? Like this case right here. This is maybe where I will highlight, right? This case right here is subtracted from the total, right? So the total number of options would be just to take the 12, these add up to 12, right? Choose 3 random groups, but I'm going to take away the scenario where you have 3 cats and 0 dogs, right? And that's where we end up. Okay. So I just wanted to walk through this once. I think it would make more sense to start working through some problems, some questions, and then come back to this as we go through it, or you actually just look through this as you're maybe reviewing. Watch, I have another indirect scenario here, password with at least 1 repeated letter. What you want to do is take the total number of permutations and subtract the case where you do not have repeated, no repeats, right? That's basically indirect how we do things. That's important to remember. Okay. All right, so let's get our booklets out. We ended up working through page 40. We're at page 48C. I gave you the answer to that one, but I want to work through that to kind of bring that back to life. Okay. Page 48. Okay. You have your calculators, have them ready as well. Okay. So if you read the very top, let's just read the general question here. How many ways can a hand of 5 cards be dealt if we talked about there are no restrictions? You just take 52, choose 5. And I must add a hand of 5, there's no order, right? Order doesn't matter, so we use combination. So this is how many possible hands can be made. We did the case where we have at most 2 blacks, so that means 0, 1, or 2 blacks, right? And we kind of laid it out. I would strongly encourage you to do this so you know what you're doing, right? Tell yourself, what am I going to do? And then do the actual computations, okay? You must have at least 2 hearts. And remember, groups of 5, right? So at least 2 hearts means 2, right? Or 3, or 4, or 5, right? 2 hearts, or 3 hearts, or 4 hearts. Do you think doing the direct route, would this make sense to go direct, or should you go indirect? Right? If you add these up, okay, you would arrive to your final answer. But then you also have, where would I do this here? I want to be, so if I go total minus 1 heart, sorry, I need to start with 0 hearts, right? Like, let's say I go total minus, let's say a scenario where I have 0 hearts, and I will subtract a scenario where I would have 1 heart in my in that hand. This is indirect, right? And I just broke this here. This is indirect. Indirect. Reasoning. This would be direct. Okay. So does it matter which way you do it? Not really. It could mean a few extra minutes of work doing it one way over the other, but I don't think it's going to be critical. Okay. So let's just start writing this out. What would this look like? The total number of hands we already established in A. From 52 cards, you're going to choose 5 at a time. That's your total number of combinations. Minus, how many hearts are there? I actually remember something now. I need to make a confession here. I threw you off, right? I think this is wrong here. Ace 2 to 10, Jack, Queen, King. I think this is 2 to 9, Jack, Queen, King. So make that change, please. I don't know if you wrote this down at the top of this page, but it's otherwise you have more than 52 cards. So that was I just noticed that after the fact, so I apologize for that. So let's jump back here. So 0 hearts, the scenario where you have 0 hearts, there are 13 hearts, and you'd be choosing none of them, right? But you got to make sure that you account for the rest. So what would the other part be to this hand here? You have 13 out of 52. That means that 39 cards. Are you following me here? It's a Monday morning. There are 39 that are not hearts, right? So how many am I going to choose from those? I'm going to choose the 5 that I need, right? And then, so that will take care of the 0 heart scenario. Then I will subtract another case where out of the 13, I'm going to choose 1. And out of the 39 remaining cards, I would choose 4. And here's where I would like to just notice that, right? This is your hand, right? Hand of 5. So you should always notice that, right? The R's, this is R, right? Those two always combine to your hand of 5. Okay, that's very important to understand. And what do these two here? Is this gonna throw you off? 52 cards, right? Always remember, you have your 52 cards like that. That's how I came up with the 39. I basically said, hey, 52 cards together. I already used like 13 are designated to this one. Therefore, 39 are for the rest, right? So it's hearts, not hearts, right? And so let's compute this further. So I'm going to go 52. Let's clean this up a bit. 52 choose 5. What's 13 choose 0? Anybody remember? It's 1, right? And 39 choose 5. That one I will have to compute. You remember the shortcut, guys? So you go 39, alpha, and then window. Alpha window calls this. I'm so glad that Isabel told me this. It makes life so much easier. 39, choose 5. So it's 57, 57, 57. That's pretty cool. Right? So that takes care of this part. Minus, what's 13 choose 1? Bonus question. 13. And then 39 choose 4. I'm just going to copy and paste, right? Whoa, 82, 251, right? And now 52 choose 5. I'm just going to go to A, by the way, right? I'm just going to, and this is just 1 times 57, 575,757 minus, I'm going to go 13 times 82, 251. That's 106.9263. And here's my total. This is false advertisement. I bought these at Amazon. They said they don't break. These lead refills. False advertisement. 259, 89.60 minus. I'm going to go copy that answer minus this one. You're left with 953. 940 hands. Okay. I don't want to go direct, guys. It's too much work. I did it in my original here, I think. No, I went indirect. I didn't. This is too much work. So I actually chose this method in this particular case. But I think it's to me at least, right? This is helpful to write out what is the question saying. At least 2 hearts means I need this or this or this or this, right? So you need to add all these cases. I decided, right? I'm going to go total. I'm going to consider 0 and 1 hearts, right? Subtract that and then get my answer that way. That's indirect right there, folks. Keep going. So this could have been, I just want to add because I can't do every scenario, but this could have been face cards. There's 12 face cards, right? So that means that there are 40 that are non-face cards. So same principle, right? It would have been 12 and 40, right? 12 and 40, you still follow the same kind of scenario there. I want to talk about dependent events. So go to 49 here. Dependent events. What does that mean? Well, as the name kind of indicates, the first task affects the second task and so on. Maybe the power will go off and you'll be all happy, right? Anyways, keywords. Items are not being replaced, right? Items are not being, objects, people, right? You name it, not being replaced. I don't know if you came across this in the homework, but there is one like this. Okay, so let's say you're organizing an event and you need to split 15 students into smaller groups. Okay, if you need to create groups of 4, 5, and 2 groups of 3, how many different groups can be formed? Okay, so there's one I think that talks about putting students in like tents, different size tents, or putting students in various cars. One car can hold 4 people, one 5, and so forth. It's the same thing. So I will put that putting people into cars, tents, etc. is done the same way. Okay, I'll put that on as a note on the side here. It's Monday, so I need to slow down a bit, I know. I want to make an emphasis on this, right? You see groups, right? Groups, groups, groups. So what should you be thinking of? Permutations or combinations? It's a combinations, classic giveaway. You're making groups. It doesn't matter, no specific positions or stuff, right? So combinations. I will start just calling it comps, right? Like that. Perms or comps. That's what in math how we just refer to that after a while. So what you do is you choose out of the 15, you make your first group. So let's say the first group is a group of 4, correct? So choose your 4, and you still need to keep going. How many students are left if you chose 4? 11. So I'm going to go like this. Minus 4. So I'm down to 11. And I'm going to choose how many? What's my next group? 5. I'm going to choose 5. And how many are left now for my third group? I went from 15, I took 4, right? I went to 11. I take another 5 out of my total, right? So we are at 6, right? 6, choose I need to make two groups of 3, right? So 6 choose 3. And notice how my total is going down, right? I took 3, how many are left? 3 students, and I need to make another group of 3. So you've placed, now you've made groups of groups for everybody to put, you've used them all up, basically. So let's calculate that. 15 choose 4, can I just tell you what that is? I think you're okay computing this, so that's 1365. 11 choose 5 is 462. 6 choose 3 is 20. 3 choose 3, anybody? That's just 1. So I do this and I give the answer because I want to show you something else that's pretty cool in my opinion. Ways. You can make this many different combinations of students. But what about this? Let's say you're like, well, what if I had started with the groups of 3 and then worked my way this way? Do you think you get the same answer? Let's try that. Or start with groups of 3, right? What if we did it that way? So I would start with 15, I choose 3, I'm left with 12, and I choose another 3, I'm left with 9, right? Remember, 15, I take away 3, I'm left with 12. I make my second group, then I make my group of 5, I'm left with 4, and obviously I need to choose 4 yet to fill in that last group. And so 15 choose 3 is 455. Okay, 12 choose 3 is 220. 9 choose 5 is 126, and 4 choose 4 is just 1. You still get the exact same answer. So with these types of questions, it doesn't matter which car you fill in first, which tent you fill in first. But I think what I need you to notice is what happens to the total, right? Right? I will put that on the side here. Total decreases as groups are being formed. I'm gonna park that there. I think I'm gonna keep going here. I want to go to page 53. Combination meets permutation. This page only. It's rare, but I want you to at least have seen some examples. You will come across that in the review that I give you. A volleyball coach has 12 players. He'd like to know how many teams can be made with a setter, libero, and 4 other players. Right? So you're like, okay, teams, that should kind of tell you, hey, this is probably leading to the combination branch, but then you have specific positions, right? So I will say this: specific positions mentioned, therefore it's a permutation, right? But then for other players, right, this is combinations. So setter, libero. So let's do you have basically your setter, your libero, and you have 4 others. Okay. So for this, right, you have how many options do you have at the very beginning? If you use the fundamental counting principle, you have 12 for the first position, 11 for the second position. How would you fulfill this part here for others? That's where you would just go, since you've used 2 positions already, how many are left now to fill the 4 remaining slots? There are 10, and you need to choose 4. Okay. So watch, this is a little messy here, so let me just go down here. So this is basically 12, pick 2 times 10, choose 4. Because you pick 2 from the 12. And since you've already picked 2, your remaining option, you only have 10 left to choose the 4 remaining players. Okay. So, and notice that you're making teams. That's the overarching kind of theme here. So combination should be part of your solution, right? So let's just go ahead and figure that out. 12 pick 2 is, we'll just go 12 times 11. Let's just do that for this. Times 10 choose 4 is 210. Okay. So this part is right here. This part is right there. And when you multiply these out, you get 27,720 ways. Or teams. Sorry, I should say teams. Because you're not arranging, right? You're making teams. So you couldn't have just done 12 choose 6 because of the specific positions mentioned here. What if John is the libero? So you have setter. Come on, don't fail me now. Here, setter, libero, and 4 others, right? 4 others. So John is the libero. So there's only one option really, right? So that needs to be fulfilled first. If there's something mentioned like this player must be that means that you have 11, pick 1 to fill in this spot right here for the setter. Okay. And still you've used 2 slots, 2 players, so 10 choose 4 to get the remaining 4, right? So this is 11 times 1 times 10 choose 4 is still 210. So this is 2,310 teams. Because now, right, John used to have 11 slots to fill that libero position. Now there's only 1 filling in that libero position. What if John or Nitish are setters? So let's do this again, right? Setter, libero, 4 others. Okay. So John or Nitish, right, are setters. So that you have John. How should I do this? John here, Nitish. So you have 2 options here. It's kind of like the or. You have 2 options there. For the libero position, you have 11. You need to pick 1. And you're like, wait a minute, Mr. Dirksen, I just used 2. Don't I have 10 left over? No, it's or, right? It's John And then there's 11 left, pick, right? Because if you pick John here, Natish could be included here, or vice versa, right? And then 10, choose 4. So this is really 2 times 11. 11, pick 1 is 11, right? And then 210. So that'd be 4620 ways. And if you think about it, it's twice as many options as you had before, right? Because you have 2 possible positions to fill that in. All right, let's do, so this is combination means permutation. This is, how should I say this? Very rare. But if it does come up, I wanted you to at least have seen it, okay? Okay, this might be like if I give you A, B, C, this might be a D question in a problem, right? Whereas like, hey, wait a minute, like why is it like positions and then just fill in the rest with teams, right? With other players. This is how that looks like, okay? Objects and rows. Can you do this one here, right next door, 54? When a question mentions people sitting in rows, it only affects the number of permutations if people must remain in their row. Okay. If people must, right, like whoever is in this row has to stay in there, then this technically turns into groups. Okay. So watch this. I just use this as a reference here. So let's say you have 12 people sitting in rows of 4, right? So there's 3 rows, 4 in each, right? So you have to think of these must stay together. What does this look like, guys? Doesn't this look like grouping, right? It's almost like you could put these rows side by side and it's just 3 big groups, right? They must stay together. So within each group, right, there would be 4 factorial because you can rearrange these people, right? 4, 3, 2, 1. Within this group, you have 4 factorial. Within this group, you have 4 factorial. So this is like G1, G2, G3. And so we'll do the calculation right here. What if every person must stay in their row, right? Grouping question, put that down. Grouping question. So we're going to go G1 times G2 times G3, and then we're going to go total minus G1 minus G2 minus G3 plus, how many groups have we formed? In this case, we formed 3 groups. Oh, don't forget the factorial, guys. There's factorial everywhere. So the first group is 4 factorial, the second group is 4 factorial, the third group is 4 factorial, and then you can tell that it's going to be 3 factorial, right? Because these 3 groups can be shuffled. You can move the groups as long as you stay within the row, okay? You have to kind of stay with that row, but you can move the rows themselves, okay? So there's 12 minus 4 minus 4 minus 4 plus you've created 3 groups. You factorial that. So it's 4 factorial, 4 factorial, 4 factorial times 3 factorial. So this part right here is just to make sure that it always works, but you could have predicted that it would have been 3 factorial, right? So I will put this up here, just go 3 factorial, because you can move the rows as long as you stay with the people stay in their row, you can still move the row itself, okay? I'll just tell you this. This is 24 times 24 times 24 times 6, right? And that's 82,944 ways. What if there are no restrictions? What if there's absolutely no restriction? You can just move people around. What would you say if you had to rearrange? If it told you that there's rows of 4, right? So 3 rows of 4. If you had to rearrange it without restrictions, that would just be 12 factorial. It's just 12 factorial because you can, right? This 12, 11, 10, you can just move people around like this. It almost turns into a straight line question, right? So it'd just be 12 factorial here, which is 479, 001, 600. So 479 million and then some ways that you can arrange that group, or actually the group of 12, right? Without worrying about anyone staying in a particular row. They can just shift around all over the place. And that's it for new stuff. I want to do one solving for n question because that one wasn't, some of you struggled with it. So I will fill in one of the blank pages there. So let's go to page 50 here. I think I will let you have a go at it because I think you need to wake up a little. So go to page 50. It says extras. Solve for n, right? And we will always assume that n is an integer. State restrictions, right? State restrictions. So let's try this one here. N plus 3. N plus 3 combination 2 is equal to 10. Let me just cut out a piece of loose leaf or something. Maybe not. Can you give that one a try? How would you even set this up? Okay, can you do this? I will highlight this part right here. N plus 3, I will highlight. Do you remember the formula for combinations? You better have that on your study sheet. Watch right here on the NCR is actually n factorial over r factorial, and then you would just go n minus r factorial. This is the combination formula. This is what we're going to use to get ourselves started. So watch this, guys. I'm going to rewrite this in terms of the formula. Okay? And notice that the highlighted part goes at the top here. So we go n plus 3 factorial, and I'm going to highlight that again to show you you've inserted this whole thing up here and put a factorial on it. That fulfills the n factorial part, right? Whatever is in here shows up here. And then you go over, this is your r, and the formula called for r factorial down here. So we're going to go 2 factorial. And this is the part that confuses most of us. And that's normal, but you just follow along. What does the formula call for down here? It says whatever is here, right, take away r from it. Whatever is in here, take away r from it. So in this case, it's n plus 3. I'm going to take away 2 in this case. And then slap a factorial onto it like that. And remember, the equals 10 doesn't go anywhere. Let's highlight the n plus 3. That part right there. I will leave the rest up to you for a little bit here, okay? Just use pencil. If you make a mistake, we'll just make a correction there. That I gave you. Okay, so here we go. See how we did. So remember, right, this just gets plugged in for n's on the original, and we're using NCR, not NPR. So you got to make sure you get that right. And so I will clean this up a little bit. 2 factorial is just 2, right? We can drop the factorial. It's 2 times 1. And n plus 3 minus 2, that's just n plus 1 factorial. And don't forget the 10. Oh, and now I'm going to hold it for a bit. What's the restriction? We've got greater than or equal to negative 3, and then greater than or equal to negative 1. Which one should we be picking? The overall restriction is the greater one. Okay? Because then you don't need to worry about the lower. So then we will expand the greater expression. So n plus 3 times n plus 2 times n plus 1 factorial over 2 times n plus 1 factorial. Okay, we cancel out the n plus 1s. Allow me to FOIL this out already. Okay, so n squared 2n plus 3n plus 6 is equal to 10 all over 2. Don't forget about the 2. Maybe at this point I will multiply both sides by 2. Okay, so I times this by 2, and technically you want to show it like this maybe, right? That's the best way to do it. So that gets rid of the 2's here. You're left with 20 on the other side, and I'm already going to collect my like terms. Is equal to 20. Okay, you bring the 20 over, so it's n squared plus 5n plus 6 minus 20 is equal to 0. And then it's n squared plus 5n minus 14 is equal to 0. If you got this far, you're doing pretty good. Right now it's just how are you going to solve this? Quadratic formula, factoring, or using your calculator. But just make sure you show me the keystrokes if you're using the calculator. I don't want to just see n this and that, right? You need to show me how you got there. So n, I'm going to factor it. Right? A little trick, the first sign I put in the first, and the product of the signs I put in the second. That's one way. Then you know one is positive, one is negative. And so I want 5n to be left over. So two numbers multiplying to 14 is 2 and 7, 1 and 14, right? 2 and 7 will work. If I put the 7 here and the 2 there, I'm going to get plus 7n, right? Minus 2n ends up being 5n there. So n is equal to negative 7 is one option, n is equal to 2 is the other one, and this is the one that passes because that one is greater than or equal to negative 1, right? And that you're done. You can then plug it back in if you want. Check, right? We can check. I'm going to go 2 plus 3 C2 is supposed to be 10. 5 C2 is supposed to be 10. Sorry, not 0, 10. And I'm just going to go 5 C2 is actually equal to 10, so you're good. 10 is equal to 10, right? Just a quick check. Yes, can you guess and check? You can guess and check, but you wouldn't be getting marks, right? Some students just try plugging in. They have this on their calculator and they're like, what if it's 5? What if it's 6? What if it's, right? And then they match that. It's like, oh yeah, it must be. If it's 6, right, they would just say n is equal to 3, right? So you have to show me, like, that's the whole point, is the algebra that is associated with finding the answer. Look at that piece of left there. Away with you. Anyways, so that's that. If you want more, okay, more that are challenging, right? Hungry for more? Page 281, question 15 specifically. Question 15 specifically will do the trick there. If you need help, just come and see me. It won't take long. I'll put you on the right track there. Another thing, if you go with me all the way to page 56, all the way to page 56, I inserted a worksheet there which is reviewing permutations and combinations. Okay, so at the same time, at the bottom of this page, at the bottom of 56, there's a chapter self-test in the book, right? So that's page 291. If you want more, I just want to give you like resources. So you could do this starting 56 all the way to the end. This worksheet right here. You can do the self-test, or you can do that handout I just gave you, and you're like, that's too much, I can't handle it. The handout you just got, I'm gonna use that tomorrow to like blast through and get you ready for the test. That's what I'm gonna use. My suggestion would be, in all honesty, work through the handout I gave you so that you're ready to just watch out for little things that you didn't catch while you were doing that worksheet. And then this is kind of like in addition to whatever is here on 56 or whatever is in the textbook, that's in addition to what we're doing. That would be my suggestion to you. I must also warn you, the handout I just gave you, I ran out of room for most of those questions, so you might want to use loosely for the handout I just gave you, okay? So maybe if I go to 58 here, page 58, I'll just say for review, right? First option is handout. Second option is page 56 to 58 in the notes. And then third option is self-test, page 291 in the text, right? So these are your three options there. So